Welcome to our discussion on the emergence of carbapenem-resistant Escherichia coli co-harboring BLA CTxM199 and PBP3 insertions, which confer increased Astrionam avibactam resistance in South China. Carbapenem-resistant E. coli, CREC, poses a critical public health crisis, causing life-threatening infections. The most common clinical presentation is urinary tract infections. Intra-abdominal infections carry a high mortality risk, while sepsis can be rapidly fatal without effective therapy. Treatment options are severely limited, highlighting the urgent need for new solutions. The role of novel beta-lactam-beta-lactamase inhibitor combinations is crucial in combating New Delhi metallo-beta-lactamase producing carbapenem-resistant Enterobacteriaceae. Astrionam remains stable against metallo-beta-lactamases, while avibactam inhibits various enzymes. The Astrionam-avibactam combination, approved by European Medicines Agency in 2024, offers a promising treatment for multi-drug-resistant gram-negative infections, though emerging resistance is a concern. This study overview focuses on South China surveillance from 2022 to 2024, involving 291 carbapenem-resistant Enterobacteriaceae isolates from 23 Grade A tertiary hospitals across 6 cities in Guangdong Province. Whole genome sequencing was conducted using Illumina X Plus and Pacific Biosciences Revio platforms. 14 antimicrobials were tested using broth microdilution according to Clinical and Laboratory Standards Institute M100 guidelines. Our study utilized advanced bioinformatic tools such as PROCA, ResFinder 4.0, and ISFinder for genomic analysis. Reference strains included E. coli ATCC 25922 and P. aeruginosa ATCC 27853. Additionally, 130 BLA CTx-M199 positive genomes were retrieved from National Center for Biotechnology Information for a comprehensive global epidemiology analysis. BLA CTx-M199 is an emerging extended-spectrum beta-lactamase in South China, found in 8.9% of carbapenem-resistant Enterobacteriaceae isolates. It ranks third in prevalence, following BLA CTxM55 and BLA CTxM14. Notably, 96.2% of BLA CTxM199 positive isolates show Astrionam avibactam non-susceptibility, with 38.5% fully resistant, all within sequence type 410, and also harbor BLA NDM5. The cohort consists of 291 CREC isolates. Urine is the most common specimen source at 36.4%, followed by sputum at 15.1%, and blood at 14.4%. Notably, 97.6% of these isolates harbored BLA NDM, with BLA NDM5 being predominant at 93.8%. Astrionam avibactam resistance in these isolates results from the synergy between BLA CTxM199 and penicillin-binding protein 3 insertions. BLA CTxM199 hydrolyzes Astrionam and reduces avibactam inhibition efficiency, while YRIK/YRIN insertions in penicillin-binding protein 3 alter the Astrionam target. Neither factor alone confers full resistance. Their combination is essential. In comparing ATM-AVI susceptibility, 100% of BLA CTxM55 positive isolates were susceptible, whereas 96.2% of BLA CTxM199 positive isolates were non-susceptible. Both groups had YRIK/YRIN insertions, highlighting BLA CTxM199 as the key resistance driver. The BLA CTxM199 positive isolates are linked to high-risk clones ST410 and ST167. ST410 shows full resistance to ATM-AVI, with minimum inhibitory concentrations of 16 to 32 milligrams per liter. In contrast, ST167 exhibits intermediate susceptibility with an ATM-AVI minimum inhibitory concentration of 8 milligrams per liter, universally featuring the YRIN insertion. The genetic context of BLA CTX199 varies between ST167 and ST410. In ST167, it's located on an approximately 18.4 kilobase chromosomal fragment, flanked by the MHP gene cluster and lac operon, with ISECP1 facilitating mobilization. In ST410, it's plasmid-borne on an approximately 62.7 kilobase INC-I2 plasmid, enabling both vertical inheritance and horizontal gene transfer. Conjugation experiments reveal that plasmid transfer significantly drives resistance spread. Transconjugates with BLA CTX199 exhibit a 16 to 32-fold increase in AsTrNM minimum inhibitory concentrations, and a 2 to 4-fold rise in AsTrNM avibactam minimum inhibitory concentrations. Increasing avibactam to 8 milligrams per liter restores susceptibility, confirming an enzyme-mediated mechanism. Notably, conjugation was successful only in sequence type 410 donors, not in sequence type 167. Now pay attention to this, which I did not see coming. Combination therapy using CAZ-AVI and ATM shows promise. Checkerboard assays reveal 42.3% synergy with fractional inhibitory concentration index less than 0.5 in 11 out of 26 isolates, and 57.7% additivity with fractional inhibitory concentration index 0.5 to 1 in 15 isolates. Notably, ATM at 16 milligrams per liter significantly reduced CAZ-AVI minimum inhibitory concentrations to less than 0.125 milligrams per liter. Our analysis of 156 genomes reveals that ST167 is the dominant BLA CTX199 positive Escherichia coli strain globally, comprising 62.2% of cases. Notably, ST410 emerges as the second most prevalent type. PBP3 insertions are nearly universal, present in 80.8% of strains, and even more common among New Delhi metallo-beta-lactamase co-carriers at 93.8%. ATM-AVI resistance has emerged in China, driven by BLA CTX199 and PBP3 insertions in high-risk clones. INC-I2 plasmids can spread BLA CTX199 to carbapenemase-producing Enterobacteriaceae, threatening CAZ-AVI. ST167's chromosomal integration ensures vertical inheritance, while its unique gene repertoire aids ecological success and spread. BLA CTX199 is a key driver of ATM-AVI resistance prevalent in South China CREC. Its synergy with PBP3 insertions is crucial for resistance. The ATM plus CAZ-AVI combination shows promise as a rescue therapy. Urgent surveillance and detection of BLA CTX199 are essential to control its spread. Screen for BLA CTX199 in carbapenem-resistant Enterobacteriaceae isolates, especially sequence type 410 and sequence type 167. Check for YRIN insertions with BLA CTX199 to predict AsTrNM avibactam failure. Consider AsTrNM plus ceftazidime avibactam as an alternative for AsTrNM avibactam non-susceptible carbapenem-resistant Enterobacteriaceae. Enhance avibactam concentration to 8 milligrams per liter to potentially overcome resistance. Published in Journal of Infectious Diseases, 2026.